All right. This is an episode of Listen to Tony, and today's guest is Erik Kulu, and we're going to talk about space. And so I wanted to start with asking you because it's becoming a hype topic, and everyone has seen Star Wars, and especially for people who are younger, there's Elon Musk, and there are people who kind of talk more and more about the space, but we don't really know what going to space/space tech actually means. Um, and maybe just taking a step back, why even go to space?
Hello. Why go to space? For me, I think life is one of the rarest things in the universe, especially conscious life. It took about like 3 billion years of evolution to get where we are, and humans were so close not to almost happen. We could have died out many times in history. But we are here now, and we are actually conscious and able to create technologies. And um, so life might be one of the rarest things in the universe, like really, like the rarest things in the universe, and that seems something that's worth protecting. Um, and now, or like for the last 50 years, we actually have technology where we could go beyond our Earth, also settle, for example, Moon and Mars, and even further. And by doing that, we would basically ensure the survival of humankind. Um,
So you think we're doomed if we stay on planet Earth?
Maybe not in short while, but it's not a question of if asteroid it will hit, it's more a question of when it will hit. So at some point asteroids will start hitting Earth. Even more, people might not know that sun is actually getting hotter tiny bit every year. It's not what's causing the climate change, but let's say in about 1 billion years, sun will get so hot that uh, and also Earth will get hot that all the oceans will boil.
No.
Yes, so that's really happening. When life was born, Earth, sun was also colder. So already in 1 billion years, life on Earth becomes almost impossible. So if we want to, if we want to ensure this rare life continues, we have to go. That's the only way, or we have to move like the planet further from the sun. So
Okay, so it has to happen though. So
so
like,
so looks and like there is it's probably very unlikely that life will evolve to go into space on like naturally, right? So
mm,
the only way to go to space and ensure that all other life, plant life, animal life, will survive is for humans to create the technologies and go and take every other life with them. So
do,
that,
do
yeah.
you, and maybe we shouldn't get into that rabbit hole, but do you think there's life outside of planet Earth? Like, are we going to encounter like some other species, or when we if we start or when we start exploring other planets?
I hope so, but like I'm 50-50. Like maybe there is no other life. And even if there is, I think the life is probably very different. Our culture would probably be very unique. And that's like another reason that we have so many people on earth trying to like protect something built over something. We have our culture, languages, everything that took thousands of years to get to. And it could be wiped out in minutes.
By an asteroid?
Yes.
All right. So what?
Or nuclear war, for example. Yeah.
Yeah,
Mhm.
let me say I'll go there. But like, before we continue this topic of like actual space exploration and what are the like in the near future, what could we do to actually further the efforts? I'd like to ask you like, why did you get into space in the first place? What's the and is it hard? You know, like when you're growing
Mm.
up, like, is it what do you have to study?
So I don't know where it fully started, but as a kid, I remember my mother bought like encyclopedias that were translated to Estonian and had good pictures. That was maybe before we had internet. So I remember watching those encyclopedias and like the space bars, their planets and space shuttle. Um, I remember being disappointed maybe in like late 90s when I found out that we actually had not gone to Mars. I had the impression that we also landed on Mars, maybe because of some movie trailers, but yeah, we haven't. Um, but
You're
then,
like, no shit, like
yeah,
does that motivate you? Like, yeah, you want to make it happen because it.
no, it was never like something that was like that seemed realistic. So for a long time, I planned to go study like computers, some kind of computer hardware robotics. But then I think in the final grade, I realized that physics might be the way, because physics as a base would allow to do all those, help to develop all those cool technologies. And then so I got into physics, but then like few weeks after in the summer, there was news that hey, we are starting to build satellite in Estonia. And Estonia doesn't have any space companies. You can't learn it in university. There was no traction towards doing space, or no Estonians were working in space companies and so on. So we really started from scratch. And most of the team who built that satellite was either physics students or computer science or software. And we also had many non-technical fields helping to do the project management and marketing. And
Do you have the government come in and say, "Okay, we want to be part of this because it's the first Estonian
no,
team," or I don't know, the Ministry of
eventually,
Defense, or
eventually, but it took a long time, and we had lots of critics and opposition initially. People ridiculed us and so on.
what was the
But
process? Like, how do you start even? You're a physics student. Your country has no space program and no kind of knowledge slash, and then you just say, okay, we want to do it. And of course, there are people doing it in other countries, and you have the
yes.
internet, and you can Google stuff. But overall, like, how do you even start? If say you're a kid in Zimbabwe today, and you wanted to launch a rocket, how would you go about it? I mean, probably different reality, but you know what I mean.
Mhm. I mean, in Estonia in 2008, it was actually just Googling. So many other university teams had done it already. So we knew it was like plausible. We knew approximate costs, and we did start reading like theses from other university graduates from other countries, and that's how we developed the base. We read books, and then we started building our own prototypes, because ultimately, like satellites or spacecraft are mechanical engineering, electronics engineering, electrical engineering, doing the boards, PCBs, and then software. So all those three main fields are something that people do have skills in, and then you need only a tiny bit of space-specific knowledge that you can read from books.
Mm. So how long did it take to get from you, like you and your friends thinking, okay, we want to do this, to actually having like a viable prototype and sending it to space?
No, I mean it took us 5 years to finalize the thing we sent to space, and we actually did not put like a full prototype together like 6 months before the space launch.
Shit, what was the 4.5 years before
Um,
that?
Lots of paperwork. Like we did do studies. We designed the satellite on like paper in different software, in mechanical software and electrical software. We did have like prototypes for like single subsystems, and we
What
kept
is a single subsystem?
for example, so satellite has, let's say, a main computer that does most of the monitoring and processing.
Mm.
That's like one subsystem on a satellite. Communication subsystem, power subsystem that takes energy from panels and puts it to batteries and distributes it. So, yeah, many very specifically defined systems.
And from like drawing the different d- drawing out whatever you want to build, what was the, because that seems like the fun part for you. What were the challenges though? Because you can have ideas, the physics, right? But actually making it happen, apart from, I guess you got to contact the European Space Agency or whoever you launched or we can get to that later. But um, what are the actual hard steps? Like, what are the steps to actually getting a satellite into space?
I guess yeah, like doing the hard, once you actually get to prototyping, it is the fun part. But I was part of the system that dealt with like the measuring the orientation of the satellite and changing the orientation of the satellite. So, for example, if your satellite has a camera, then which way the camera is pointing, and making sure it points like on a location on Earth you want to take picture of. So that's the system I was involved in, and it's one of the most challenging ones. And actually, for that. Um, the mission of that first CubeSat, SCube-1, was to test electric solar wind sail. So people likely know normal solar sails. So these are these huge reflective mirrors in space that use the solar pressure of sunlight. But there is another concept that uses solar wind, which is like charged particles that also come from sun. And that sail basically generates like a big magnetic field around the sail, and then the charged particles from sun basically bounce from that magnetic shield and then transfer a bit of momentum, and that's what pushes the sail.
And we already use that?
No,
Oh,
we,
okay.
we wanted to be like the first test in space to demonstrate the principles of that electric solar wind sail.
What would you use that sail for? Is it just like, is it instead of a propulsion engine or?
Yes, it's like a propellantless propulsion,
Okay.
right? You don't normally you need propellant or fuel in space to push your spacecraft, but with that you only need electricity, which you can get from sun or nuclear, and that because it would be like so efficient, it could achieve higher speeds. So the thought was maybe we can use it to like send some like very distant spacecraft to explore the furthest planets and objects in the solar system.
Got it.
Like faster missions to Pluto and even beyond.
So designing that, and so we said like it didn't work out. You guys had that idea. How?
It wasn't our idea, but
Okay, yeah. So you basically there's some papers on it, and you thought, okay, we can actually build it. How did you stay? Because it took 4.5 years to actually get to building a prototype. How did you stay, I guess, motivated / sane around this idea? Because you can have passion, but also like, especially in nowadays of like everyone chasing these quick rewards, and also you're young, you're 20s, right? Like you're seeing your peers probably, I don't know, getting kick-ass jobs or whatnot, and you're grinding on building some satellite that even though you don't even know if it's going to work out. How's that?
I mean, it was hard, and like I was probably close to quitting too at some points. Very hard. What helped was that most people were in university, so you did do your thesis works on the same topic, so that helped to keep yourself involved. And I think most of it was just like momentum and sticking with it. So we had weekly meetings. We did have a bit of accountability. So we had very cool workshops in summer and other like breaks in the weekends out of university. So these were the yearly regular milestones where all of us got together and presented the latest results. And
what were the breaks about? Like, where'd you guys go?
There were like physics summer and autumn schools. So we did our events part of that. And yeah, one of the best memories. We had so much fun.
What'd you guys do?
I mean, nothing too crazy as university students, but still, yeah, like good fun, cool times.
Yeah, I guess physics camp must have been interesting in Estonia. Who guided you? Because if no one's been doing this in Estonia, and then I know there's Uncle Google, but other than that, like
we actually had a visionary leader that was one of the professors in the university. He was the motivator. He was the great speaker who always motivated us. He presented everywhere.
What would he say?
Sorry?
What would he say to you? Like, what's the apart? Like, because you can hear these speeches from like I don't know Elon, but
like initially the asteroid thing was common. So he was the one who originated that. It's not the question if asteroid hits us. It's the question of when. So that was one of the early primary aspects. Yeah.
Okay, got it. And so how was the launch itself? Prototyping, who did you contact? Like, who do you get in touch with if you want to launch a satellite into space?
I mean, there are companies that will help you. So, but for that you need money. We didn't have much of it, so we actually got lucky. So, the chair of our parliament of Estonia knew the director of European Space Agency personally somehow before. So we got like super lucky that she just asked him, "Hey, will you launch our satellite or not?" And he said yes. And after that, it almost became like a political decision that yes, our tiny satellite will launch on this ESA rocket at that time. And then I know a lot of people were actually quite annoyed inside European Space Agency because of how that played out.
Why?
I mean, it's not the regular way of doing things.
Okay.
But yeah, and eventually, I think government together with European Space Agency also found the money then to pay for it. Yeah.
why did they pay for it? Just because you guys were Estonian, or was there like this? Was it how was it portrayed, say, in the Estonian media, or
I mean,
what was the reasoning behind it? Why would you? Because yeah, you're using taxpayers' money for this, right?
I
So
mean, people were very excited. Like everyone knew about it in Estonia. Like it was famous for years after that. We could have a meeting with anyone from Estonia. Like when we did like the second project, we did some marketing campaigns with like Estonian president. So for example, Estonia has these Starship robots that do like food delivery.
mm,
Um, so we did like a PR stunt where that Starship robot took like a painting of the. So with the satellite, we took a photo of Estonia. That was one of my prized outcomes of that mission. Estonia fully cloudless. It took us lots of hard work to get that photo, but yeah, we used that robot to take that photo to president, and that was covered in public news, for example. So
and the Starship or Starlink robot.
Starship robots,
What
yes.
what is that?
It's one of the most exciting Estonian companies. So it's like it's like a robot with six wheels, and it's mostly empty. And so you can either order like takeout or like groceries with it, and it will come to you instead of like a courier. It's like a robot that will bring you that food.
And that already you can see it on the streets of Tallinn. And
Yes, lots, and in many other countries too.
really,
Yes.
so basically, you have this like little device roaming around the streets, um, driverless.
Yes, eventually, yes. It has lots of cameras, AI, machine learning, like self-driving.
Wow,
It can
I've
cross
never
the
seen
roads.
this.
Yeah.
When did they launch it?
It has been many years now. They have. It's. I think the most. It's operational
Estonia lives in
now
the future, huh? Like I've been there in a while. And it's like,
I think it's mostly active now in like university campuses in US and some cities in UK and yeah.
okay, well, I need to get my shit together. I never heard about this.
Yeah.
I also wanted to ask you, how often are these satellites, or sorry, these rockets launched? Because I guess it was also about like you're lucky with timing, or does ESA like launch a rocket every few months, and it was just like a question of which one do you get on?
Yeah, no, at that time it was difficult. So SpaceX has really made a difference and now launching like twice per month approximately. But at that time, yeah, some rockets maybe only launched once a year, maybe twice a year. ESA maybe did like up to 10 missions per year. So yeah, approximately once per month. But you couldn't just randomly get on board all of them.
Got it.
Yeah.
And so, okay, you guys sent it into space. You took the photos, met the president. You're big shots in Estonia.
Mhm.
What happens next? Like, what's the because we're building up towards the kind of the space based uh, infrastructure projects that we're talking about nowadays. But before we get there, what happened? What happened next?
What happened next? We started trying to build the second one, but it still hasn't launched. So the second one is taking longer than the first one, unfortunately. But few pairs of people actually did their own startups right after that. So small space startups, first ones in Estonia. Some of them failed, mine failed. Some of them are alive, and some of them are growing now.
Well,
And
yours failed, so you started a new one.
um, not directly.
Okay,
Then I went to get a job.
yeah. Because why did it fail? Was funding an issue, or you didn't have an idea, or that would like was viable?
Mm, Um, Lots of reasons. So I guess we underestimated the market size for the products we wanted to do, and we also underestimated the time it would take us to fully develop these products for space.
What were the products?
Like mechanical structures and deployables for satellites.
Mm,
So, for example, like structural frames for those same small CubeSats and solar panels that are deployable and different things like that.
and that was like late 2000, like
That was 2014, 15. Mm.
okay, and that wasn't viable back then. Like even with all the
I mean, it's
money, and
still no, the money wasn't flowing at that time. That was partially before the hype emerged, and the market size is still nowadays small. So I think it was probably smart of us to close it down. Yeah.
Okay. And what kind of job did you get? Did you stay in space or were you?
Yeah, yes, I went to Scotland, Glasgow, to work as like a space system engineer, building more satellites at even faster pace.
What does it mean to be a space system engineer? What is that?
Um, I guess we are in a way like generalists. So maybe good comparison is like product managers who also do some work on their own. So
Mm,
maybe they test the product, maybe they do some coding, maybe some marketing, talk to customers.
okay,
Mhm,
got it. So you spent there, what, 2 years?
mhm.
How many satellites or did you launch with the guys from Glasgow?
Uh, Maybe 3 or 4 that I definitely had my hand on building and finishing up. Yeah.
Did it become almost like just like shipping? Was it shipping a new product every time, or was like you launched the first one, second time it would get just easier and easier, and you would know the ropes. That's why you left after the fourth one.
A bit definitely. Luckily, the very first one I did there was like the first satellite of that company after a few years. So like a second satellite for that company, but first one from the new generation. So yes, indeed, there were lots of like challenges. There were many things we in the company were doing like for the very first time, like still leading the way. And that was exciting, jumping into the unknown again. But yes, after the fourth one, even though the missions were different and satellites were different, it still became more doing the same thing over again.
And because in this case, you didn't have the ear of the Estonian, I don't know, like minister or whatever, the politician that helped you out. So in this case, how did the company get their satellites into space? What's the process? Say like I have a satellite company or I want to build a satellite company with my buddy. How do we get into space?
So some rocket companies sell you directly like a slot on the spacecraft on the rocket. So let's say you can go to SpaceX website and buy yourself 50 kilos for 275,000,
Shit.
and then um, it has like specifications. But yeah, basically, if you if you add like a special interface to your satellite, which then connects to the rocket, that's pretty much it. You also have to do some testing to prove to the rocket maker that your satellite doesn't like fall apart during launch, because that would endanger other satellites. But yeah, it's become quite commoditized. So
Okay.
um,
So you just buy a spot, send it in, and
mhm.
for you guys, it was just part of the every annual planning. Okay, we want to send like 3 or 4 satellites. We have to
Yes.
have like 1 million or 2 set aside for that, and then for
Mhm,
R&D. And
mhm.
okay, got it. And what happened after that? What
After
because you got bored, like you kind of became you learned a lot, but you were like, okay,
mm,
I'm done with sending the satellites. Um,
already at that time, I had my first websites, nanosats database, so I was keeping eye on what's happening in the space industry. And
what are
um,
the websites called? So you can
nanosats database that mostly
.com.
follows those same tiny CubeSats, nanosats.eu, and also follows like constellations and companies in the nanosatellite field. So nanosatellites are satellites below 10 kilograms. Then after that is New Space Index that follows all kinds of satellite constellations, and also rocket launchers, so small rockets. That's newspace.im, and the latest one is Factories in Space, factoriesinspace.com, following all the new emerging fields in the in-space economy and in-space manufacturing fields. But but yeah, I took that job because after doing the startups, I didn't have any savings left, so I just needed to build up some savings. But already then I knew that I would jump into doing my own startups again. So I left after about 2 years because I had some ideas that I wanted to explore. Um,
So you just left Glasgow, but didn't you go to Canada before?
I went to Estonia for approximately a year and worked on those ideas at least part time. So I continued doing some remote work for them, operating a satellite. But yeah, I really explored few startup ideas.
So what happened in that year? Because like as I said, you later on you went to Canada. So
Mhm.
uh,
Those ideas got stuck. So I
what
couldn't
were
either.
they?
Making diamonds in space was one of them.
Diamonds. Yeah. Okay.
Diamonds in space. And the first one was making C-band optical fiber in space. So C-band is like a new type of optical fiber for to like distribute internet very fast. And at the time, the thinking was that this might be the first profitable product we can do in space. We can only do that in microgravity. And if we do it in microgravity, we bring it back to Earth and sell it to Earth. And it was thought that it could be like the first profitable product because you could get like kilometers of fiber out of 1 kilogram of like the uh, in like the class form input class, and then yeah, the thinking was that you could sell that few kilometers for higher price it would take you to make it in space.
Why diamonds in space though?
Diamonds was more like a fun idea. So, regular mined diamonds do have some ethical issues, and I get that. But the solution to that is lab grown diamonds.
Yeah.
Pretty cool, but maybe not romantic. So thinking
Oh.
was that maybe doing lab grown diamonds in space would be like give that extra oomph and rarity to make lab grown diamonds cool.
Probably a
Yeah.
nice premium too, huh? Like
Mhm.
diamonds from space.
Plus, diamonds is something that like 1 kilogram of diamonds is very
Yeah,
expensive,
fuck
so
done, yeah.
that will cover your launch costs. Yeah.
Got it. And so you didn't do it because you felt like you couldn't find the right partners or it wasn't the right time?
Um, uh, Doing diamonds in space was more difficult than I imagined. So, lab growing a diamond actually needs lots of electricity. That was the main barrier. So, just needing like tens of kilowatts of power for months in row was even a challenge on ISS at the time. It's probably easier in the future, but yeah, just like power availability in space, and then also you do need large quantities of like some gases like hydrogen, and
Mm.
taking those gases to space is still difficult.
Isn't it like that with most things related to space? They seem easy from like you just think about it. Oh, like let's send a satellite or let's do
Mhm.
I don't know, beam lasers down from Earth and like blow up shit or something. And you realize there's so much that's still unknown, like not figured out, slash extremely costly. Um,
Yeah, I think so. For example, within space manufacturing, so yeah, if you think about like some kind of manufacturing process that we have on Earth to do some like metals or something,
mm,
then yeah, it's people don't often think that in that manufacturing process you often need lots of energy, electricity. You need maybe lots of water to process something, maybe some other gases, and yeah, those resources are difficult to get in space. So um, electricity and water are still like relatively cheap on Earth, and you do need them for many manufacturing process. So that's maybe one barrier.
but why is electricity? You mentioned electricity and water. I get the water part, but you said electricity is for free in space, right? Because you just have like a solar panel and
Yes, but uh, electricity on Earth is still like very available. You can get it very easily in large
oh,
quantities
okay, yeah,
just by
so
connecting in. So if you need those large quantities in space, you do have to build your own solar panels and connect them up. So it's still like difficult. You can't just plug it in and get it immediately. So.
got it. And
Mhm.
so then what did you? Because you didn't start another company, but you also didn't want to do the same thing you've been doing in the past. So
Mhm.
what was your decision making process about the next step?
Um, so from Scotland time, the first satellite I built was for a Canadian company called Kepler.
Yeah,
And when we built our first satellite in very intense 5 weeks, we actually got quite close.
5 weeks to build a satellite.
Not fully, but yeah, we did a large amount of like the assembly, integration, and testing in 5 weeks. Probably had no weekends.
Is it like if you want to get like the like for assembly, do you just go to Home Depot or I don't know, like
No.
and you just buy all the shit that you need and you assemble it? Like how does it work? Or do you have to contract some factory and give them a blueprints of what exactly you want to make and
In the middle, yes, but by that time we had all the parts, but it
okay.
was like we had to put it together nicely. We had lots of issues because we were doing it the first time, so some things did like burn up, so we had to replace some of the parts. And there was just and there is lots of like testing steps. You had to take it to like vibration testing. You need to do um, uh, radio testing in a similar room where like the RF signals would be blocked off. So yeah,
We were in a soundproof
mhm,
room. That's what he meant. The same room.
uh,
But yeah.
so lots of testing, but yeah, we got quite close during those 5 weeks. So in a way, we already knew that we want to work together, and but then it was more about getting visa to be able to go to work in Canada. So I got that visa about like a year later.
Okay, so while
Mm.
you're in Estonia, you already
Mm.
knew you want to go to Canada, and
Because the ideas got stuck, then yes, I always had that the backup in mind. Mm.
it's like a side question. Like, I get like the part about like you design and you need some parts, like tailor made for you. But is there some like, I don't know, Amazon for space like
Yes,
parts?
says yes, but every satellite is still a bit different because the missions are different. So while you could do like a common satellite, at some point you probably want to optimize the design to be more like cost, mass, and like more efficient to do your mission. And like even though that Amazon exists, it's still you can't just like plug in every system. You do have to design something. You do have to probably do the software or at least advance the software. So there is still yeah. It's not only plug and play.
Okay,
It's not yet like a desktop computer.
so every satellite is a new innovation to an extent.
Not fully. I mean, there is still a lot of like reinventing the bicycle, which could be better, but um, um, and like that's okay for like first missions, first demonstration missions. But if you if you ultimately want to do like a satellite that might earn lots of revenue and maybe even become profitable, then you likely do need to optimize that satellite. Yes.
And you make the revenue by whatever service the satellite provides
Mhm.
by like taking photographs
Or
or
communications. Yeah.
communications. Got it. Because so, but if you and I say, or someone like has a few hundred K to blow and really wanted to have a satellite, they could go online, buy the
Yes.
parts, assemble it, and then maybe hire someone to help them with like the programming part of like, making the satellite communicate in the right way with whatever device slash software you're using back on Earth, and that's it.
Basically, yes. But I mean, it would be then easier for you to just buy the whole satellite from someone directly rather than put it together yourself. There
Yeah.
are still many steps that can go wrong, and not all of them are like compatible with each other. So
Mm. So what happened in Canada? Why didn't you give up on building your own thing, or what?
I never did.
Yeah, what did you do there?
Um, in the I went to Canada because they were building like a batch of like a constellation of satellites. So like many identical satellites. So again, here, there, we built like the first satellite in their facility. That was exciting. And then we built 8 identical satellites in less than 2 months. That was a new experience because to do 8 in 2 months, you do need to like optimize the process. You need to almost get into like serial manufacturing mode, like
Yeah,
they did the first Model
Ford.
T cars. Yeah, so that was the first time I got that experience and saw it firsthand. So it was a new, very beneficial learning.
Just like seeing how it is to scale a space
Yeah,
company
manufacturing. Yes.
manufacturing. Yeah.
Hmm.
Um, what does it like? How many satellites are there in space? Because it seems like you said like, okay, here,
Thousands.
yeah. How does that
Like
even work?
SpaceX has already sent like I think close to 3,000. So overall, maybe like 10,000.
Do they
Uh,
crash into each other? Like, is there
no,
some like,
space is big. Space is
yeah,
very big. So imagine, um, so imagine like surface of Earth, right? And you have lots of cars, but space, you have like thousands of layers of surface, right? Almost like flying cars. If you had flying cars, then you could have like multiple levels of roads where the cars drive, so collisions become way less likely. But space has like thousands of layers of those like roads or
so they exist?
orbits.
There is a traffic system in the
No,
orbit.
no.
Okay, so they're just counting on that. Okay, I'm gonna put my
Yes.
satellite on this altitude, and it's gonna be good.
Yes, because like the distances between objects are so large. They do collide sometimes, and sometimes if they detect collision is likely, they like use propulsion to maneuver. a bit, like change their orbit a bit to ensure that the collision wouldn't happen. But yeah, even by chance, these are still very, very unlikely.
Okay, got it. Um, so you've seen the how to create a process of manufacturing satellites.
Mhm.
Um, you could have stayed there, right? You always can stay in a given job, but why did you leave again? Because you left, because that's why
I
we're
mean,
talking.
like as soon as we finished those 8 satellites, I on the side I jumped back into exploring startup ideas. So even when I was there, we try. Always worked on some, explored some concepts. We applied one idea to test stars. We almost applied another idea to Y Combinator. Um,
What were they? What are the ideas? Like, what are people like? What's hype right now in space tech? You know what I mean?
it's not only about hype.
Yeah,
Yeah.
but also,
Mhm.
what's something that you'd really want to dedicate your next 10 to 20 years to? That's also viable, right? Because
Mhm. Yeah, that's the main challenge. So, like rockets are probably like too saturated now.
mm,
So SpaceX was amazing and was able to revolutionize rocket launch, and even now no one else has caught up with them. But they were not the first. But yeah, maybe rockets are like okay, that's off the table. Then next step was satellite constellations. So lots of satellites doing a similar task. So especially low Earth orbit constellations doing either communications or Earth observation. But uh, I guess partially that maybe feels saturated too. So lots of players moving a bit slowly. Markets maybe not catching up fast enough. Most of them not having large revenues. So yeah, maybe not an easiest thing to do, and it's really hard to think another type of constellation that might provide value. And then, so besides satellites and rockets, what are the other fields in space which could make money also? So lots of cool ideas in theory, but yeah, what are actually like businesses or could be businesses? Um, don't know. Like that's actually a very big challenge.
but what did you apply
Uh,
like to Y Combinator and Techstars with? What were the ideas?
I think so. Some solutions, potential solutions, are, for example, very large telescopes. So one of my dreams would be to build 1 kilometer diameter space telescope to actually see like exoplanets properly,
What are exoplanets?
um, planets around other stars.
Okay.
But now our telescopes are too small. We can't actually like see them close up. We can't see if they have oceans and lands
Can
and
we just
maybe
send
even
a
life.
satellite there?
It's light years away. It would take hundreds of years to
What is
get.
a light year? You know, you kind of like go into light
Mhm.
speed. You know, like in Star Wars. Like, what does that even mean?
Well, so light travels at the velocity of 300,000 kilometers per second.
Okay, it's fast.
Our satellites travel about 10 kilometers per second. So light travels 30,000 times faster than our satellites. Getting there, we don't really know yet. But yeah, it's a crazy speed. So, and even if the closest stars are about 4 light years, so even if we could achieve close to light year, it would still like take 4 years. If we could achieve
And a light year is the speed of light.
of light.
Okay, yeah, light
Mhm.
year. Yeah, yeah, okay.
Um, so yeah, so light year is the distance that light travels in a year. Mhm.
Whoa, okay. And it's like 300,000 something
Kilometers per second.
per
Yeah.
second. And so
So,
seconds, how many seconds in a year? Fuck. Okay, that's okay,
it's a lot
far.
of distance.
Yeah.
Um, but the closest stars are 4 light years. So even if we could achieve like 10% of light speed, it would still take us 40 years to send a satellite. But we also don't have technologies to get to that speed. So yeah, for the next few decades or a century, we probably have to just watch and not go yet.
Okay, so that didn't
Mhm.
pan out and you were
But
applying.
but yeah, the idea there was that to get to that large telescope, you would have to build it in space. But there, like many of those things have like chicken and egg problem that even if we get the billions to build it in space, who would be the customers? Most likely, science community wouldn't pay enough revenue to make it like
Mm,
economically sustainable. So where are the customers? So one commercial idea for such a space telescope is also observing Earth. You could have that in like geostationary orbit. So in geostationary orbit, such telescope would look like it's fixed over the sky. So to you, it would be like orbiting over a specific location. And the thinking is that if you had such a big telescope in space at geostationary orbit, uh, you could take photos of one specific location on Earth all the time, 24/7. So and probably the resolution would be better. So for example, it would likely have more like military applications.
Yeah, because I don't imagine like
Yeah,
getting
but
creeps to get on
mhm.
that and just like take.
I mean, you probably wouldn't recognize like a face. The resolution wouldn't be that good, but you could maybe haven't done the numbers, but you could maybe see like a car.
But
Yeah,
would I see it from if I was
no,
standing on the street? Okay,
maybe.
it's quite big. Yeah.
Hmm. Only if it would reflect the sun. So maybe that's at some points.
Got it. And why not rockets in a sense, like try build like a first military or just like a rocket that actually could fly around like all the like the Falcon whatever the Falcon was in like
Mhm.
in Star Wars or like just a vehicle that would help you travel to different planets. Um
We don't know what's like the engine for that. So that's something no one has figured out yet. What would be the engine for a spacecraft that can travel very fast in space? Um, Now our engines need fuel, but that fuel is burned up quite quickly. So we need like a total revolution to figure out what would be that space engine um, to travel fast between planets, to travel faster than light. I hope it will become possible one day, but that uh, then is breaking maybe some physics. So let's see if that will be possible. Um, like one option is maybe like antimatter. So like antimatter drives. So when normal matter and antimatter combine, that like releases huge amounts of energy, more than like you get from nuclear and fusion.
Whoa.
So like 1 gram of antimatter would allow you also like super fast speeds, but humankind also isn't ready to generate to produce that large quantities of antimatter just yet, and storing it is still an issue. But maybe antimatter will be the
How would we
future.
produce it, or why weren't we ready?
In particle accelerators, basically CERN,
Yeah,
you would
yeah.
need similar things as CERN, but maybe commercially focused, producing antimatter, and then you still have like storage issue. But yeah, maybe that will be like the engine for a future Millennium Falcon.
Yeah, yeah. Huh.
That's
Um,
something I would like to do too. But yeah,
because we can do it now, right? Like if you got enough money to build like a large like hydrogen accelerator.
particle accelerator. Yeah, maybe like we are going a bit off topic, but I'm also a big proponent of nuclear energy, and maybe fusion is a bit far away still, because fusion does have some more like scientific fundamental challenges rather than just like engineering problems.
What is
But
nuclear fusion? Just for like.
um, so the energy of how stars are powered. So combining combining the lightest elements in the university at very high, super high temperatures, millions of degrees Celsius, and very high pressures, and they at that time, in those conditions, basically, let's say two hydrogen atoms are able to overcome the electrostatic force that pushes them apart, and then basically they combine, and that releases lots of energy.
Okay.
Uh, so that's fusion, but before that, I think we could do a lot more with nuclear fission. And one path there is what's called subcritical accelerator-driven nuclear reactor. So it's a type of nuclear reactor where the amount of fuel is less than critical. So let's say if something happens, it would never explode. But with normal nuclear reactors, you always have to like slow down their reactions, because if you stop slowing down their reactions, it could blow up. Like
Yeah.
that's what happened in Fukushima, and yeah. But with that reactor, the fuel amount is never critical. So it's safe. And then you have particle accelerator that sends protons to it, which starts like the nuclear reaction. And then if something happens, you just turn off the particle accelerator and everything stops immediately. So it's like a safe nuclear reactor.
It
And
generates a lot of energy.
yes, like it's like net positive. Even though you do use energy for that particle accelerator, it's still like net positive. And that nuclear reactor is also able to use other spent nuclear fuel. So, with nuclear reactors, storing the old fuel is like a big problem, right?
Mm.
It's done underground, but that reactor is able to actually use up that fuel, old fuel from other reactors.
No
And that
way.
reactor leaves only tiny amounts of residue. So that's much easier. It hasn't been built yet, but I really think that has some potential. So
Why aren't you working on it?
I never met a nuclear person.
Okay, fair enough.
That idea needs at least one person with nuclear background. But yeah, I want to.
Maybe you'll
Plus,
now. Yeah.
another way how we could go further in space is nuclear energy. So nuclear based like space engines. That would be another path how we could travel much faster to Mars and Moon and other places in the solar system. So I do want to do it. And like we probably need nuclear energy to power things beyond Mars. So if we want to go beyond Mars, we probably need nuclear energy anyway. So it still comes back to space, right? Like for me, everything's connected to space. But with that, we could also benefit the Earth a lot, right? By again providing lots of cheap and space energy 24/7. And there, because you would be basically the first company to do like a commercial particle accelerator,
Mm.
there might be a next step where you use those commercial particle accelerators to do antimatter. And maybe before you can do some medical isotopes for the MRI machines and so on. But yeah, that path could also lead to antimatter. So
But going to energy, because energy
mm,
is the fundament of our progress
yeah.
as a species, and we
Mm,
mentioned at the very beginning, like we do need to get the fuck out of this planet at some point.
mhm.
What's going on? And because you left, again, of going back to Earth, and like you being in Canada, what's happening now? Why did you leave? And then what's the focus now in terms of energy and space?
Uh, I felt it was time to leave after almost 3 years and 2.5 years in Canada. It's definitely the time to try some startup again. And um, like the challenge has always been that where are the markets? In theory, there are so many exciting technologies that we could develop and that would have exciting applications like big space telescopes. But yeah, to do those things, you do need to think about where do you make revenue. Not even profit, but yeah, you do want to make revenue to make the company sustainable, economically sustainable long term. So where are the revenues? Like, and besides rockets, SpaceX also discovered internet. So internet in the world is about a $300 billion business.
Mm.
And then internet in space, also like a next future.
What do you mean SpaceX discovered internet?
They discovered that internet could be a good business
Okay.
for them to enter next. So they are Starlink,
Yeah.
SpaceX building Starlink, internet from space, and I think they want to capture like maybe 10% of it. That would be a $30 billion business every year. And they think maybe that internet business will then bring them enough revenue to then fund their Mars missions, right? So using internet to make money, but then fund cool, exciting development. So yeah, that's like same with
Mm.
Google, right? Google has search engine that sells lots of ads. That's how they make money. But then they are able to investigate all those cool, exciting things that they have done in the Google X,
Yeah.
Alphabet X subsidiary, right?
Yeah,
So
his commercial part is very important,
yeah.
and like you always want to make money. But I'm curious, like just explainer, what's the difference between having space internet and like the internet that we have right now?
Mm. So so fast internet doesn't reach many places on Earth. The fiber cables just haven't been pulled there, and it's expensive to take a cable to some location, right? But with internet from space, and if that internet comes from low Earth orbiting satellites, you can get basically the same speeds you can get with fiber internet. So that's the idea. You can bring internet anywhere on Earth, especially like the
Is it like with signal, like telephones, and we
y-
went from telephones to cell phones
yes,
and
partially. But yeah, the benefit is you can get your cabin in Alaska now and actually do remote work there and have nice calls. That's what they're enabling, and it's actually a big business too. Um, what's also coming next is directly linking mobile phones to satellites. So that's also appearing now. Apple just announced it in their iPhone 15 presentation that you can send emergency messages in remote areas straight from your iPhone to satellites and then to authorities. So that's like another field, but it's still like telecommunications. So using space and using satellites to do some kind of communications between locations on Earth.
mm,
Existing business, big business, but yeah, it's already something that big players are trying to capture. So yeah, the question is, what's next? What's next after rockets? What's next after telecommunications? How can we use something in space uh, to make some revenue, and preferably the markets are on Earth?
yeah, and so you look on planet Earth and look what's going on right
Yes.
now. What are the needs and what are the topics that's like pretty
Mm.
much on the agenda of every major country on this planet is the energy crisis, I
Mhm.
guess.
Electricity.
Electricity, sustainability, right? Climate change.
Mhm.
Um,
Um,
so it's related with like non-renewables and
mhm.
then renewables and intermittency. So
So,
what space has to say about
uh,
that? What does space have to say about that?
maybe I won't get to electricity right away, but some other thoughts I've had is why I've gotten into in-space manufacturing is more sustainability, climate sustainability. So,
Mm,
um, my and it's not only me, but let's say in 100 or 200 years, we could move most manufacturing to space and then make Earth into like a global nature reserve. That's one of my dreams. That like in space there is no life, right? So if you have like a manufacturing process that maybe
it's
melt
toxic or
that's toxic in space, it wouldn't damage anyone.
mm,
And like space is full of those radiation toxic materials anyway, right? Yeah, so in space there is no nature to harm. So all of those toxic things we could move to space and just do it there, and then Earth could be clean, fully clean, harmonious, like solar punk style, fully green cities. Um, so that's one of my dreams, how we could help Earth significantly via space by moving factories to space. Um,
why don't you do it? Why aren't companies doing it now?
I mean, the profitability is difficult, right? So
Still, okay.
getting to space, building those factories there,
And water,
bringing
electricity, okay, yeah,
so
you mentioned.
it's still like very like far away. So, but yeah, that's the dream. Um, so so yeah, the goal has been to like how to make in space manufacturing happen. Um, can we find a way how we could maybe make a new type of material in space that we can then sell on Earth, just like Seaplan? I don't think anyone has figured it out yet. So it's more like a fundamental problem of doing more studies of what could be those goods and products and materials that we can only do in space, but then sell on Earth. So no one knows. But yeah, like that's the dream. So for years, I've been looking into this topic, trying to figure it out. What could be the first killer app, as you say, right? Killer something that would create new value in space and maybe kick off more space activities, right? Because then once you get the snowball running, it will like stimulate all kinds of other companies in space. So if you have factories in space, you need more launch, so more commercial customers for launch. You need to bring them back. You need electricity. You need resources. Let's say you have a factory in space, and then one company is, hey, I can bring you water cheaper from asteroids than you can bring it for Earth. That's an immediate business model for him, right?
Mm,
But without having that factory in orbit, how do you get asteroid mining going? It's difficult, right?
mm,
So those factories in space initially using materials, raw materials brought from Earth, doing something, bringing them back to Earth. could become like first customers that could kickstart this in-space economy. That's the vision. But yeah, we haven't been able to figure out what could be those profitable things.
But some things are like not even
Mm.
speaking about profit and revenue is
Yeah.
important, but you have this, especially in the past few years, you had startups that were just raising a fuckload of money,
Mhm.
just getting customers, a lot of users, customers,
Mhm.
right? And then thinking or saying, we're going to figure out how we monetize the platform in the future, right? There's going to be some way to monetize it, get the people to use it. And then, um,
I'm
so
not sure if it applies to space. Um,
no, maybe
mhm.
not, but like, how because there needs to, at some point, like someone has to say, okay, we're gonna put up front a few billion. Probably we're not gonna get them back. Um, but we're gonna spearhead the development of XYZ technology. Um,
Maybe, but it's still better to have some kind of plausible revenue sources and market
what about
opportunities.
China, for example? Why don't they just go and say, okay, we want to have our factories? Like, because they have a lot
I
of
mean,
pollution problems. They have a lot of money. Like, they don't need to think that much about making revenue for now. I guess they could just go and build a factory in space.
it would still cost you like so much. Like it would still cost you so much more that then it's more beneficial to make those factories cleaner on Earth. There is like it's not just one leap to do them in space. It's like many,
Okay.
many, many leaps. So yeah, for a lot of things you can. There are like more low hanging fruits that you can do on Earth to
What are
improve
they? I
things.
mean, not the low hanging
Mhm.
fruits on Earth, but like low hanging fruits. What can you do in space right now,
Yes.
apart from rockets and
Right.
satellites, that it can help you, like,
Mhm.
basically become
Yes.
profitable
Mhm.
eventually, hopefully, but also
Mhm.
make revenue almost from the get go.
Yes. So coming back to electricity, energy, electricity is very large market on Earth, and now this energy crisis, at least in Europe, did has made people realize that maybe that's the market using space, but somehow using space to send or create more energy on Earth. And it's a concept of space solar power stations, so big solar farms in space that would transmit basically green electricity to Earth. And it's a concept that has been going on from 1970s, many studies, but um, it never was um, it never was like economically viable. So cool concepts, but they always cost like tens of billions. We never had the rockets to do them, so cool, but yeah, not like a practical, plausible solution. But now things are changing.
Yeah,
Um,
what are the trends? What's going on now? Why 2022 could be the first year where it actually could start
mhm,
making sense, and people who want to build a viable business would
mhm.
even look into that.
So maybe now's the time when humanity is actually realizing that climate change might be an issue and trying to do something about it. In 1970s, we still happily burned oil and gas, and I think climate change was probably some people suspected it, but yeah, it wasn't something in like people's consciousness. So now there is actually like a need and want to do things. And then the space side is actually catching up. So Starship by SpaceX, a big rocket that is 100% reusable, is able to send up maybe let's say 100,000 tons. So also lots of capacity, and they want to like mass manufacturing it. They have said that they might need like 1,000 ships to build a big Mars base. So they actually want to create like a mass manufactured rockets. So first time in history, we are starting to get the cheap mass manufactured, easily and quickly reusable rocket, which we never had in history. And that's a big change. So what that might enable, um, hopefully amazing things. Mm,
Like space-based solar power.
yes, because launch costs have been one of the major blockers to space polar power.
And when you say like solar farm in space, what does that even mean? Like, what do you
I
just
mean,
to visualize it a little bit?
I mean, let's say big solar panels, but they would be like kilometers in size. So let's say 2 by 2 kilometers of only solar panels in space. So much bigger than the International Space Station and like 100 times bigger than anything we have built in space now. So still a big leap. Um, mhm.
Okay.
And then you would either use um, microwaves, which is actually safe, but yeah, it's not like a microwave oven, but you would either use microwaves or lasers to transmit it to Earth and then convert it to electricity that you would put into electric grid.
So why isn't Elon doing it?
Um, I know he has had some pessimistic statements, but I think he will come around. So um, just like with internet, so there was a wave of satellite internet companies in late 90s. All of them failed. Iridium came out and survived, but still went bankrupt. But there was like 20 companies spending millions trying to do internet from space back then. So many years after that, it was also a thing that people thought might become viable in the future, but there you still had lots of critics. So people were pessimistic, and that has been the same with space solar power. That it has been around so long time, but it never has been plausible because the trends haven't converged. But now, but now they seem to be converging, like actually, and I do think SpaceX will do it because the opportunity is too great to pass, right? This will create the biggest space companies in the future. So anyone not doing it will be at disadvantage. Like in my opinion, they almost have to. It might be a bit early now, and I don't think it would be smart of them to like announce it just yet. But I wouldn't be surprised if they have a team working on it already. So
Got it. So I mean, commercial risk is mitigated by, okay, like this actually could, it's going to generate money, and maybe not going to be the
Mhm.
cheapest energy source, but in the
Mhm.
future could be. Um, Technological trends are coming together, but still, what's the what are the obstacles for, like, I mean, 2 by 2 kilometer uh solar farm? It's pretty fucking big, like, and
Mhm.
I mean, the rockets, I don't think they can send that to space, or like, how do you even get that big of a structure into space?
Yes, so that's the reason we are not there yet. So the trends maybe will converge in about 10 years to do the big one, 4 square kilometer sized. But the time to start now is probably now, because for example, power beaming technologies, they are starting to be demonstrated on Earth at smaller scale, but there is still like a big leap to demonstrate and build them in space at like 100 megawatt scale. It's still there are many steps in between, many increasing sizes that you have to build up to. So same with building those large structures. We haven't done big in space assembly yet. It's possible, just hasn't been demonstrated. So once we demonstrate it in small scale in space, you still want to have few stages where you build up the scale, right? You don't want to build a skyscraper right away. Maybe you build a small house first and then a
Mm.
big one. So so doing those prototypes and smaller demonstrations will still take you about 10-15 years.
Okay, what are the applications though? Like, you send energy down to Earth. What what does this unlock, this energy? And also, is it only for Earth, or like once you have such a big structure in space and you can actually beam it, why not beam it, say, to Mars, right? Say, because we, again, going
Mhm.
back to the uh us getting out of or off of planet Earth, and kind of exploring other
Mhm.
planets.
So the benefit of energy having solar panels in space is that they basically see the sun 24/7 continuously.
Mm.
So renewables on Earth, sun is limited. Also, like sun is at an angle. You might have clouds. Sun is moving throughout the day, so you have lots of blockers to receive, like let's say solar on Earth, and wind isn't continuous either. But solar in space would be continuous. So even if let's say there are lots of efficiency losses due to those transmissions and electric conversions, it's still a way to have continuous power to the grid. So it's more a competitor or replacement to oil and gas and to nuclear, like really the baseload powers. Yes. So yes, that's being continuous is maybe an advantage over pure cost in some applications.
Got it. And then this, like, space to space application.
Yes, maybe in the future, if you have big space stations, you could transmit space to space. Maybe you can remotely power other satellites while they are in eclipse, so they would need smaller batteries. There is one very active direction with the moon. So moon has 2 week long night and 2 week long day.
Wow.
Yes, at least in the equatorial areas. So
It's cold, huh?
and there is no atmosphere, right? So once you don't have sun, it gets cold super fast
Yeah.
because there is nothing to keep the heat. So one way how to power the, like, let's say a moon base during those 2 weeks of night is to transmit it from orbit, moon orbit. Second option is there are many permanently shadowed craters in moon's poles, near the moon poles, that will likely have lots of water. So in the future, we probably want to mine that water. But yeah, because it's permanently shadowed, what's the energy you
Frozen,
use in that
yeah.
crater? And like those craters are big, like kilometers in size, and like deep also. So either you pull like a super long cable, maybe fair for future, but meantime, let's say you want to explore them, you could have like a moon rover that's like remotely powered from the orbit, that's then able to keep exploring the crater, not just on battery power, but yeah, have some way to recharge.
Got it. And so
Uh,
now, like, there's this idea of space-based solar power, and it sounds amazing, but maybe without exposing the secret sauce, like how do you even go about it? Say, like, I hear this idea, and like, okay, another like you have the space like rockets, right? You have satellites, and you have space-based solar power actually viable. Like, all right, like let's get to it. Everyone who is into space right now, and hears about this, it might, or like some people might go, okay, fuck it, like I'm dropping everything. I'm starting dedicating my next 10 years to space-based solar power. How do you even start? You know, because I mean, you've tried doing different things
mhm.
and try to build startups in space that, you know, in the end you realize are not viable, and maybe this will happen with this idea, but hopefully not. So how do you plan on going about space-based solar power topic
I
and actually
want
commercializing
I
it?
want to say that the time will pass anyway. SpaceX is already 20 years old.
Mm,
Tesla is almost 20. Apple is almost 50. So the time will
true.
pass anyway, and you do need decades to build really, truly big trillion-dollar companies. And you know the famous saying that in the future you probably wish you started today, right? Like you wish you started yesterday, but now is the better time to start. Or but yeah, at least you don't want to be like 5 or 10 years in the future and realize, hey, I should have started
Mm,
at this time, right? Um, so yeah, once you see those trends and opportunity, it's time to start. And I think what I've seen by following so many space companies is that many of them who are like successful actually maybe don't come from space, don't come from like classical space industries. It's more about having having the initiative and conviction to follow some idea and keep finding the ways how it might be possible, and then building those prototypes initial on Earth. Doing that wouldn't take that much money at small scale. You don't
prototypes of like power beaming and
Yes,
like, yeah.
you don't have to jump to like tens of megawatts right away, right? You can start with
Mm,
milliwatts, single watts, so small scale prototypes, building up momentum, building up the team. The more hardware you have to demonstrate to investors, the more likely you are to maybe get the next rounds. Um, there are space companies who are raising like Series Bs, but have not maybe not launched anything to space yet.
yeah.
So it's to me, it's more about starting. And I feel that's what SpaceX did too. That there were rocket companies before. Some of them almost succeeded, but SpaceX, they were frugal, they were iterated fast, and they were more about just like doing it, getting things done quickly, and that's the mentality old space companies often don't have. And that's partially also by the reason we still don't have a good competitor to even Falcon 9, first reusable rocket. And
Yeah.
SpaceX is very close to now flying Starship, but others don't have competitor to Falcon 9. That was like 10 years ago, right? So others are just so far behind. And yeah, to me, it's more about mentality. the way we think and make decisions. It's less about if your people have like great experience, because motivated new people who are maybe not held back by their previous biases and ways of that's how we always do things are often able to do are often the ones who do that innovation and push the new limits. So to me it's about mindset.
Yeah, speaking of mindset and entrepreneurship and starting something new, what do you think about just like the competitive landscape of launching a company like this in Europe versus in the US?
Um, yeah, like US seems to be better in terms of finding more funding to those risky ideas. So the funding landscape is better, but at this point, United States is off limits for me because of the ITAR laws, restricted export laws that apply to space and and some other military technologies. So yeah, at least at this point, US is off the limits.
But do you feel it's going to be harder? You might be held back because not only I think is access to capital the only, because I don't think that should be the biggest blocker. Maybe is talent pool, or I don't know, just the fact that maybe
yes, it's harder, but I like to. My thinking is more like not finding ways why we can't do something, but more like
how you fucking do it.
how
Yeah.
maybe we could figure it out. So yes, it will be more difficult in Europe, but it's not impossible, right? So it might take a bit longer. We might get less funding. We might get more successful competitors in the US, but it doesn't mean we don't have a chance. We definitely have a chance. So yes.
Nice. What's your kind of past hour musings about space and space tech and kind of your story? What's your take, like, I guess, for the next 10 years, apart from like space-based solar power and maybe a parting like advice for anyone who wants to get into space tech?
Mhm. I think I think space industry was in a bit of hype, just like other startups. Lots of easy money, and then lots of business model that maybe don't have good revenue sources. So I do think we see some consolidation and failures in the next couple of years, but also because Starship will soon start flying, and that will only get more faster, more cheaper. I think we'll have another wave of new startups doing new things in space in the field of in space economy. We need all kinds of startups, right? Utilities, um, transportation in space. We need everything. Habitats in space. So I think thanks to Starship, we'll see emergence of new types of space companies in all of those fields. And yes,
Got it. All right, man. Thank you for sharing all that. Any parting advice to I guess people who want to get into space tech, or young physicists or people like you who are like in Estonia, in a country that didn't have any space program?
It's definitely possible. There are many international organizations like Space Generation Advisory Council, where you can try to volunteer. There are you could start your own project in that country, tiny satellites that you might be able to still fund and send to space. So it's definitely possible, and you don't even have to be technical to get into space. All those space companies need non-technical people to make them successful.
Yeah,
So yes,
to build a company. Yeah,
Mhm.
for sure. All right, exciting things are coming. I hope this time around, things will actually, the stars will align, and you get to build the company they always dreamt of building.
I think so. I really believe that now. Yes.
Fuck yeah. All right, man. It's a true pleasure. Thank you.
Thank you.